Okay, good morning to one and all. I am going to start the today's lecture, and we know that just we already started this topic before the Diwali holidays. That is the superposition or the superposition of the harmonic oscillator. You are visible. Screen is visible, Mahima.
Yes, sir.
Okay, okay, very nice. Okay, see ya. Then we know that the oscillations is due to the force, restoring force. If we take the one of the example of the simple pendulum, and simple pendulum is rest at the equilibrium position, then it can't be oscillate. If one can apply an external force to the simple pendulum, the displacement will be made from the equilibrium position, and if we release the force, then the simple pendulum will be starting oscillating about the mean position, and that will be known as an oscillation. We know that the simple harmonic motion, it will be simply known as an SHM, and it will be represented by the homogeneous differential equation. We know that the homogeneous differential equation in last lecture I will be it will be learned in very simple manner. Then if we know that the simple harmonic motion, if there is the one of the motion which will be concluded as the simple harmonic motion, and it will be represented by the linear differential equation. And see what is the form of that linear differential equation. That is the d2y by dt square is equal to minus omega square into y, where d2y by dt square is the force, and that force is acting on the particle is proportional to displacement. If the displacement of the body from the mean position is the larger, that is the displacement x is the larger, then, or the displacement y is the larger, that is the x and y are the displacement in x direction or in y direction. Consider, if the body is displaced here in y direction, means in vertical direction, then that displacement is noted by the y, letter small y. If the magnitude of the y is greater, the force is the greater. We know that is the force which is applied, external force which is applied to displace the body from the mean position, that will be known as an force. Okay, and if that force is larger, the displacement is the larger. If that force is weaker, then the displacement is very less. That is, the quantity of the displacement is less. Means that the acting force d2y by dt square, its magnitude is depend upon the displacement, or its magnitude is proportional to displacement. Here we learn that is the force, where the force is d2y by dt square, which is equal to acting on the particle is proportional to displacement y. That is, the y is the direction. That is, the direction means that the body is displaced in y direction. If we take that d2x by dt square, then the meaning is that the body is displaced in x direction. Means that x direction is horizontal axis, or the x axis is the horizontal axis, and y axis is the vertical axis. Okay, then this displacement, consider that if that body is displaced in y direction or the vertical direction, then that displacement is concluded, or it will be shown by letter y, simply y, that is small y. It will be from mean position, and it will be always directed toward the mean position. Why it will be always directed toward the mean position? Because if we release that body, then body will be came toward the mean position, displaced from the mean position to other end, again came to mean position, again displaced to the other end, and such a simple harmonic motion, simple harmonic oscillations are taking place by the body. But we know that all the oscillations, that is the amplitude of the oscillation, will be damped. It means if the simple pendulum is tied to the very weightless string म्हणजे दोऱ्याला आपण काय केला सिंपल पेंडुलम बांधला आणि सिंपल पेंडुलमला आपण काय केलं फोर्स अप्लाय केला आणि रिलीज केला तर सिंपल पेंडुलम हा अबाउट द मेन पोझिशन ऑन बोथ साइड it will be oscillating but the amplitude of the simple pendulum amplitude of the oscillatory motion will be decreasing in each oscillation it will be decay it will be decaying it will be decreasing amplitude will be decreases with respect to number of half oscillation and we know that such a decay of the oscillation will be that will be known as an that is exponential
Yes.
curve in first year we see that the simple pendulum the amplitude of the simple pendulum will be exponential decay means that as the number of oscillation will be increasing its amplitude will be decreasing and it will be shown hence we know that that is the displacement is directed toward the main position and which is shown here see here we came here which is shown by the negative sign. Important property of the such a homogeneous linear equation is that sum of any two solution is also solution. What is the important of the homogeneous differential equation? What is the characteristic of the important characteristic of the homogeneous differential equation? An important characteristic of the homogeneous differential equation is explained here, that is the sum of two solution. Consider that if there are the two solution of the equation and sum of the solution is also the solution of that equation is the important important characteristic important property of the differential equation that will be known as an homogeneous equation. And when a particle is subjected to two simple harmonic motion simultaneously, then the resultant displacement will be given by, consider that if the particle is subjected by the two simple harmonic oscillation, if the particle is in oscillatory motion which will be applied in oscillatory motion, if we consider that if it is oscillated by two simple harmonic motion, if it is oscillated by two simple harmonic motion, then there are the two displacement. Then what is the resultant displacement? Resultant displacement is the addition of two displacement. It is the sum of two displacement. And here when the particle is subjected, see here the sentences shows that when the particle is subjected by the two simple harmonic motion, then simultaneously, then the resultant displacement is given by, it is the resultant sum of the two displacement y1 and y2. If the y1 is the one of the displacement, y2 is the other displacement, the total displacement or the resultant displacement is the y. If the y is equal to, then y is equal to y1 plus y2, that is the resultant displacement, where y1 and y2 are the displacement produced by the individual simple harmonic motions, and this is known as the principle of the superposition. So, principle of the superposition, which is possible only in the case of the homogeneous linear equation. And we know that if the resultant motion is also the solution of the equation, also the solution of the homogeneous equation, then this is known as a principle of the superposition. And principle of the superposition which is possible only in the case of the homogeneous linear equation. And this principle of the superposition will be satisfied only in condition of the homogeneous linear equation. होमोजिनियस लिनियर इक्वेशन मध्ये फक्त कंडिशन सॅटिस्फाय होते. लिनियर इक्वेशन नसेल, नॉन लिनियर असेल तर दॅट कंडिशन विल नॉट बी सॅटिस्फाइड. that the resultant displacement is also the solution of the SHM. It is also the solution of the homogeneous differential equation. But in non-linear equation it is not possible. Only it will be possible in linear equation. Hence the principle of the superposition position will be satisfied in only case of the linear equation, friends. The resultant motion of the particle trace the curve. The resultant motion, why? Resultant motion that will be tracing the curve of the motion, curve of the SHM, and that curve of the motion will be known as an Lissajous figure. It will be known as an, friend, it will be known as an Lissajous figure. And Lissajous figure, this curve, the Lissajous figure is very very important, and Lissajous figure is the resultant motion, the resultant trace, resultant path that will be the fabricated, that will be also it will be allowed, it will be on that path the particle will be just moved, that will be the motion of the particle will be allowed it to move in Lissajous figure, and that path will be the Lissajous figure. Lissajous figure is the path performed by the particle in superposition principle, and that path will be known as an Lissajous figure. The shape of the Lissajous figure is depend upon the frequency, amplitude, and phase difference of the two constituent simple harmonic oscillation. We know that the shape of the Lissajous figure, which is depend upon the frequency of the SHM, it will be depend upon the amplitude of the oscillatory motion, and it will be depend upon the phase difference of the two. We know that there are the two different SHMs, and there are the two harmonic oscillations. And what is the phase difference? The phase difference of the two constituent simple harmonic motion, and the study of the Lissajous figure is useful to compare the frequency. We know that the study of the Lissajous figure is highly applicable. It will be highly used to compare the two frequencies of the constituent SHM or the harmonic moशनच्या ज्या काही दोन फ्रिक्वेन्सीज आहेत त्या फ्रिक्वेन्सी कंपेअर करण्यासाठी मित्रांनो या Lissajous फिगरचा वापर केला जातो. We know that is the linear homogeneous equation will be able to give the demonstration, will be able to give the explanation of the principle of the superposition of the particle. Here the linearity and superposition principle, we have to study these two principles, that is what is the linearity and what is the simple harmonic motion or the superposition of the principle. A simple harmonic motion is generally represented by the differential equation. Just we are earlier stage we studied that the simple harmonic motion is given or represented by the differential equation, which is given by what is the form of that differential equation. We know that is d2y by dt square is equal to minus omega square y. Minus is the sign because that the displacement is towards the mean position. It will be towards the mean position. It will be goes from out from the mean position and come toward the mean position, and hence it will be known as a minus. It will be denoted by minus sign. And fair, see here, very important theme of restoring force is given here, where in the restoring force depend upon the displacement y and does not contain the higher order of the y square, y cube, y raised to 4, y raised to 5, and dot dot dot. We know that this quantity of the force d2y by dt square, that force will be known as a restoring force. And restoring force is depend upon the frequency, it will be depend upon the displacement. We know that if the displacement is the larger, the force is the higher, or the displacement is the very less, then the force is the weak. If the strong force, then force is the strong, then the displacement is the large, and the force is the weak, then the displacement is the very less. Okay, and it does not contain the higher quantity, or it will be higher order of the displacement. It does not contain y square, it does not contain y raised to cube, it does not contain y raised to 4, or dot dot dot. If there are the n number of the order, it does not contain in case of the homogeneous linear equation, and such equation will be known as an linear equation. If the equation, differential equation, which is known as an linear and which is known as a non-linear, the equation which does not contain higher order of the displacement, that will be known as a linear. If it contain higher order of the displacement, then it will be known as an the non-linear. If the equation contain, next line, see next line, if the equation is contain higher order term, then it will be known as an non-linear equation. If the displacement, that is the higher order of the displacement, is contained in the equation, differential equation, that equation will be known as a non-linear equation. If only raised to 1, that is the other order of the y raised to 2, y raised to cube, does not contain, that equation will be known as the linear equation. Here just know the discretion between, just please understand the discretion between the linear and non-linear equation. Which is the linear? Which does not contain higher order of displacement. Which is non-linear? Which contain the higher order of the displacement. Where is the very this is a very simple comparison in between the linear and non-linear equation. Here we are going to see which is the linear, which does not contain higher order of the displacement. Linear, non-linear, which contain the higher order of the displacement. Okay, next. Secondly, we notice that equation 1 does not contain the term independent of the y, and hence it is known as an homogeneous equation. See equation number 1. In equation number 1, on the left hand side and right hand side, there is the term in terms of the y, in terms of the displacement. Displacement in y direction, displacement in vertical direction, that is d2y. Y is the dependent, that is the dependent. Independent, that is the term which does not contain the y, the term which does not contain the displacement, that is known as an dependent and independent. See here this is the dependent concept. This term is dependent term on both sides. d2y by dt square, it contains the y, means it is dependent on the displacement, it is dependent on the y. Please consider the RHS. In RHS, minus omega square y, that is here also that terms contain the y, means it is dependent, it is not a independent, it is dependent on the displacement. Friends, secondly, we notice that in equation 1 does not contain independent of the y, means it is dependent on y. Not dependent, not independent, means it is dependent on y. It means in both, on both side of the equation, the term contain the y, terms in terms of the y, the quantity which are showing on the LHS and RHS are contain the y terms, and hence it is known as an homogeneous. What is the why it is homogeneous? The terms in the equation are not independent on displacement. All the terms are dependent on the displacement, and hence this equation is the homogeneous. See that? The equation number 1, d2y by dt square is equal to minus omega square y, is linear as well as the homogeneous. Why it is homogeneous? Because terms are not independent on y. Not independent on y. Hence, this is the homogeneous. If the equation, next line, please read it. If the equation contain terms dependent on y, then it is known as an non-homogeneous. Which is the non-homogeneous? If the in equation terms are containing or terms are not depending on y, terms are not depending on y, it means terms are, that is the rather than y, it does not contain y, then it will be known as an dependent, that is the independent term. And if the terms are independent, then that will be known as an non-homogeneous equation. It means that, friends, this equation number 1 is the linear and homogeneous. It is not a non-linear, and non-homogeneous. It is linear and homogeneous. And if the equation is linear and homogeneous, then then there are the two solution, and sum of the solution is also solution of that equation. That is the one of the characteristic, is very very important characteristic, and that will be satisfied by the linear and homogeneous equation. That is the property of the homogeneous equation. Linear equation is that the sum of two equation is homogeneous. That is the sum of, if the y1 and y2 are the solution of the equation, then y is equal to y1 plus y2 is also solution of that respective equation. This is the one of the important characteristic. Then if the equation is homogeneous, if the equation is linear, then sum of the solution is also solution of that equation, and that will be known as a principle of the superposition. And principle of superposition is state that, friends, this is the statement of the superposition. That is the superposition, that is the principle of the superposition theorem. Superposition state that when the particle is subjected to two simple harmonic motions simultaneously, then the resultant displacement y is the vector sum of the individual displacement they can produce. That is the y is equal to y1 vector plus y2 vector. And it is important to know that only homogeneous linear equation obey the obey the principle of superposition. Principle of the superposition will be only obeyed by the linear and homogeneous equation. And what is the statement of the principle of the superposition? States that, this is the statement, friends. Just I am making it ब्रॅकेट आहे ना, ब्रॅकेट जो मी रेड करतोय बघा, ह्या ब्रॅकेटला मी म्हटलं कॉस फाय, आणि या दुसऱ्या ब्रॅकेटला मी म्हटलं साइन फाय. ह्या दुसऱ्या ब्रॅकेटला मी म्हटलं मित्रांनो साइन फाय. काय केलं बघा, त्याला कॉस फाय म्हटलं, त्यामुळं ए इंटू कॉस फाय, ए इंटू कॉस फाय, आपल्याला याला काय म्हणता आलं, a1 a2 alpha 1 alpha 2 are the constant, and we can put a into cos phi. या एवढ्या सगळ्याला आपण a into cos phi म्हटलं, त्यामुळे याला cos phi म्हटलं, a into sin phi म्हटलं, आणि sin phi म्हटल्यामुळं नाउ स्क्वेअरिंग मला काय मिळालं बघा इथं, a into cos phi मिळालं, आणि a into cos phi चा मी स्क्वेअर घेतला, a स्क्वेअर into cos phi स्क्वेअर आहे. इकडचाही मला स्क्वेअर घ्यायला लागेल राईट हँड साइडचा. a1 into cos phi 1 म्हणजे a1 into cos of alpha 1 प्लस a2 into cos of alpha 2 याचा स्क्वेअर घेतला मी. आणि याचा स्क्वेअर कसा येईल आपल्याला माहित आहे, a प्लस b चा स्क्वेअर म्हणजे a स्क्वेअर प्लस b स्क्वेअर प्लस 2ab, माहित आहे ना. अगदी तसा आपण किती स्क्वेअर घ्यायचा, a1 cos alpha 1 प्लस a2 cos alpha 2 याचा स्क्वेअर आहे. पहिल्या याच्यामध्ये काय आलं बघा, a1 स्क्वेअर cos alpha 1 स्क्वेअर प्लस 2 into alpha 1 cos alpha 2 म्हणजे दोघांचा गुणाकार घेतला, 2 into a1 a2 cos alpha 1 cos alpha 2 a2 स्क्वेअर cos alpha 2 स्क्वेअर. आता साइनचा पण असाच घ्यायचा मित्रांनो, या साइनचा पण आपण असाच घेतला, याचाही आपण असाच घेतलेला आहे बघा, असा स्क्वेअर घेतला. आणि स्क्वेअरिंग आणि ऍडिंग या दोघांची जर ऍडिशन केली मित्रांनो, ए स्क्वेअर प्लस साइन स्क्वेअर प्लस कॉस स्क्वेअर साइन स्क्वेअर प्लस कॉस स्क्वेअर बरोबर 1 येईल आपल्याला आयडेंटिटी वापरल्यानंतर. आणि इथं मित्रांनो a1 घेतलं, इथं आपल्याला 1 येईल, a2 घेतलं, इथं 1 येईल, आणि ही टर्म येईल. म्हणजे आपल्याला इन अभाव इक्वेशन जर आपण पुटअप केलं तर आपल्याला काय काय मिळतंय बघा, दॅट इज हे a1 स्क्वेअर प्लस a2 स्क्वेअर इंटू कॉस ऑफ आहे, हा जो कॉन्स्टंट मिळतोय मित्रांनो, हा जो काय ब्रॅकेट मिळतोय, cos of alpha 1 cos of alpha 2 प्लस sin of alpha and sin of alpha 2, याच्याबद्दल आपण काय पुटअप करू शकतो, cos of alpha 1 alpha 2 पुटअप करू शकतो. आणि याच्याबद्दल जर आपण पुटअप केलं मित्रांनो, मी जे रेड केलेलं आहे याबद्दल जर पुटअप केलं तर इक्वेशन मिळतंय बघा, a1 स्क्वेअर, आपल्याला हे इक्वेशन मित्रांनो मिळतंय. कुठलं इक्वेशन मिळालं बघा, a1 स्क्वेअर, a1 स्क्वेअर इज इक्वल टू a1 स्क्वेअर स्मॉल a1 स्क्वेअर प्लस स्मॉल a2 स्क्वेअर 2a1 a2 आणि कॉस ऑफ अल्फा 1 मायनस अल्फा 2 असं मिळतंय. आणि टेकिंग रेशो, आपण जर रेशो घेतला मित्रांनो, ह्या दोघांचा जर दोन इक्वेशनचा, इक्वेशन नंबर 6 आणि 7 चा जर रेशो घेतला मित्रांनो, दॅट इज ए साइन, ह्या दोघांचा रेशो घेतला मित्रांनो, आपल्याला माहित आहे साइन भागिले कॉस जर घेतलं तर आपल्याला टॅन मिळतं. आणि मी इथं रेशो घेतला मित्रांनो, तर काय मिळतोय बघा, ए डिवायडेड बाय ए साइन ऑफ फाय, ए कॉस ऑफ फाय इज इक्वल टू टॅन ऑफ फाय. आणि वरती आपल्याला किंमत मिळाली. तर अशा पद्धतीने आपल्याला इक्वेशन मिळतंय मित्रांनो. आणि हे इक्वेशन, हे ग्राफिकली आपण काय करणार आहे उद्याच्याला, हे इक्वेशन मी तुम्हाला सॅटिस्फाय करायला सांगणार आहे मित्रांनो. 10-20 झालेत, आपण इथं बरोबर थांबूया. पटदिशीने आपण सगळ्यांनी चॅट बॉक्स मध्ये काय करायचं, अटेंडन्स टाकायचा, चॅट बॉक्स मध्ये अटेंडन्स सबमिट करायचा. आणि तुम्ही चॅट बॉक्स मध्ये अटेंडन्स सबमिट केल्यानंतर मीटिंग लिव्ह करायची आहे. चॅट बॉक्स मध्ये अटेंडन्स सेव्ह करा. Okay friends, please submit your attendance and then leave the meeting and go for the next mathematics lecture. Friends, please submit attendance. Okay, thank you. Snehal Dhere, Shailaja, please submit your attendance. Shraddha Kapre, please submit your attendance and then leave the meeting. Ghatge Vaishnavi, Shraddha, Jayasri, Rutuja. Okay.